It is the dawn of the 20th century. Canada is a young nation flexing its muscles, stretching rail lines across vast wilderness, and dreaming of a bridge that would unite its shores. Across the St. Lawrence River, one of the world's mightiest waterways, engineers dream of a span unlike anything ever built. The Quebec Bridge, when complete, will be the longest cantilever bridge in the world. Over 1,800 feet between its anchor arms. A marvel of steel and ambition. It would link Quebec City to the South Shore, slash travel times, and announce to the world Canada had arrived. The man chosen to lead this colossal undertaking was Theodore Cooper, America's most celebrated bridge engineer. His reputation was ironclad, his confidence absolute. He had built bridges across the continent and never failed. Politicians adored him. Newspapers praised him. And so, in the summer of 1900, work on the Quebec Bridge officially began. But beneath the fanfare lay a deeply troubling truth. The project was underfunded, under-scrutinized, and overseen by a man who, by the time construction reached its most critical phase, had not visited the site in over 2 years. The stage was set, the dream was alive, and the clock was already ticking toward catastrophe. Engineering is a discipline built on mathematics. Every beam, every rivet, every load calculation must be exact. In bridge engineering, there is no margin for wishful thinking. When the Quebec Bridge was first designed, the total estimated weight of the steel structure was calculated at 31,000 tons. This figure became the foundation of every structural decision. The size of the compression cords, the thickness of the plates, the number and spacing of rivets. But as construction progressed and the actual design was refined, that weight figure grew and grew until the true weight of the bridge was closer to 36,000 tons, nearly 5,000 tons heavier than the original calculation. This was not a rounding error. This was a catastrophic miscalculation that invalidated the structural integrity of the entire lower cord system, the very backbone of the bridge. Norman McClure, a young engineer on site, noticed something alarming in the summer of 1907. The lower cords, massive compression members, were showing signs of bending. Slight, yes, but bending that had no business being there. He measured. He documented. He reported his findings up the chain of command. His warnings reached Theodore Cooper in New York. Cooper, instead of halting construction and ordering a full structural review, sent back a message: continue work while he investigated further. That decision would seal the fate of 86 men. Before we go further, we must speak about the men, because this is not merely a story of steel and mathematics. It is a story of human lives. The construction workforce of the Quebec Bridge was made up largely of Mohawk ironworkers from Conowick, a community near Montreal whose men have become legendary in the field of high steel construction. Fearless, skilled, and celebrated, they worked the highest and most dangerous parts of structure with breathtaking competence. There were also hundreds of French-Canadian laborers, immigrants, and young men who saw bridge work as a path to decent wages. They worked in the summer heat and autumn chill, climbing steel hundreds of feet above the river, trusting the calculations of engineers they would never meet. By late August 1907, the south arm of the cantilever was nearly complete. Over 9,000 tons of steel had been placed. The structure jutted out over the St. Lawrence like a metal finger reaching toward the opposite shore. On the morning of August 29, 1907, approximately 86 workers were on or near the bridge. It was a Thursday, an ordinary workday. Some were new to the job. Some had worked the bridge for years. None of them knew that by 5:37 in the evening, everything would be gone. At approximately 5:30 p.m. on August 29, 1907, workers on the South Shore heard cracking sounds. A witness described it as the sound of rifle shots, sharp, metallic, coming from somewhere deep in the structure. Foreman Benjamin Yinser had been watching the bent cord for days. He ordered workers off the bridge, but not all of them could get clear in time. At 5:37 p.m., the south arm of the Quebec Bridge catastrophically failed. In a matter of seconds, over 9,000 tons of steel, the entire southern cantilever arm, buckled and plunged into the St. Lawrence River. The collapse was not gradual. It was instantaneous. Survivors described a single tremendous groan of metal, and then silence, save for the hiss of water and the cries of the wounded. Of the 86 workers on or near the bridge, 75 died. The river swallowed most of them beneath the twisted wreckage. Rescue operations recovered few bodies. Many were never found. In Conowake, the news arrived that evening. 35 Mohawk ironworkers were among the dead. Entire families were shattered. The community observed a period of mourning that stretched for weeks. It was the single deadliest day in the history of the Mohawk ironworking community. And in New York, Theodore Cooper received a telegram. The bridge had fallen. He is said to have wept. In the aftermath of the collapse, Canada demanded answers. A royal commission of inquiry was convened. Engineers, politicians, and survivors were called to testify. The commission's findings were damning and remarkably clear. The collapse was caused by the failure of the lower chord compression members, the very components that Norman McClure had flagged as bending just weeks before the disaster. The design had been fundamentally flawed. The weight of the bridge had been significantly underestimated. The steel used for the compression cords was inadequate for the actual loads imposed upon them. Theodore Cooper, the commission found, bore significant responsibility. He had not visited the site since 1903. He had dismissed the signs of distress reported by his own field engineer. He had ordered work to continue when he should have ordered a halt. The Phoenix Bridge Company, the fabricators and contractors, was also found negligent for proceeding without adequate verification of the structural calculations. But there was no criminal prosecution. Cooper was censured professionally, his reputation destroyed, but he faced no legal consequences. He died in 1919, a broken man. The inquiry also exposed systemic failures, inadequate government oversight, poor communication between engineers, and an industry culture that prioritized speed and cost over safety verification. These findings would echo through engineering education for decades, but they would not save the next group of workers on the Quebec Bridge. Canada did not abandon the Quebec Bridge. After the 1907 disaster, the federal government took direct control of the project, hired new engineers, redesigned the structure, and recommenced construction in 1913. The new design was fundamentally different. The compression members were heavier, the calculations more rigorous, the oversight more thorough. The engineering profession had learned hard lessons, or so it believed. By the summer of 1916, the 2 anchor arms and the 2 cantilever arms were complete. All that remained was the installation of the central suspended span, a massive 640-ton steel truss section that would be floated into position by barge and then lifted into place by hydraulic jacks. On September 11, 1916, that lift began. The suspended span was raised off its floating supports and began its slow ascent toward the waiting arms of the bridge. At approximately 10:50 a.m., a casting, one of the 4 corner castings connecting the span to the lifting equipment, failed without warning. The suspended span dropped. It twisted, and then it fell into the St. Lawrence River, taking with it 13 workers who were riding the span during the lift. 13 more men were dead. The central span, the final piece of Canada's Great Bridge, was at the bottom of the river. The inquiry this time was swift. The failure was traced to a defective casting, a single piece of metal that had cracked under the stress of the lift. The engineers who designed the lift mechanism had not accounted for the lateral forces that would be introduced during the raising operation. Once again, a miscalculation. Once again, lives lost. Once again, the St. Lawrence had claimed its toll. A new central span was fabricated. New castings were designed and tested with far greater rigor. New procedures for the lift were developed, reviewed, and reviewed again. On September 20th, 1917, a full 10 years after the first catastrophic collapse, the new central span was successfully raised into position. The hydraulic jacks lifted it slowly, steadily, until the steel clicked into its bearings on the cantilever arms. Workers cheered. Newspapers proclaimed victory. After 30 years of effort, 2 disasters, and the deaths of 88 men, the Quebec Bridge was complete. The bridge opened to rail traffic on December 3, 1919. Road traffic followed in 1929. It stands to this day the longest cantilever bridge in the world, spanning 1,801 feet between its main piers. And if you drive across it today, you cross the St. Lawrence in minutes on a bridge that carries the weight not just of steel and concrete, but of nearly a century of human ambition, failure, sacrifice, and ultimately, triumph. In 1922, a Canadian engineer named Herbert Halton approached Rudyard Kipling, the Nobel Prize-winning author, with an unusual request. He wanted Kipling to write a ceremony for engineers, a ritual of obligation and humility, a reminder that engineering is not just calculation, it is responsibility. Kipling wrote what became known as the ritual of the calling of an engineer, and at its center, a ring, a plain steel ring worn on the little finger of the working hand. The legend, though debated by historians, holds that the original rings were forged from the steel of the collapsed Quebec Bridge. Whether literally true or not, the symbolism was absolute. Every time an engineer's hand moves across a drawing board, the ring would remind them of the price of error. Today, every graduating engineer in Canada receives this ring in a solemn ceremony. It is called the Iron Ring, and every ring carries the implicit memory of August 29th, 1907, and the 75 men who never came home. The Quebec Bridge did not just teach engineers to calculate better. It taught them that their calculations carry human consequence. That confidence without verification is not engineering. It is gambling with other people's lives. That lesson is the truest legacy of Canada's greatest engineering failure, and its most enduring monument.